Now we're going to look at time series that has trend, seasonality, and of course the random fluctuations. In such a case, you have to use what is called a centered moving average approach. The simple average like what we did in the previous example won't work. So we have, all right, what we're going to do is we're going to use this data. Okay, so we have 3 years worth of data, so that's good. Okay, and this is the actual sales, and we have to come up with this centered moving average, and then only we can compute the seasonal ratio. So how do we come up with the centered moving average, and why do we need centered moving average? So we will look at that in the example. Okay, first let's set up the data. Okay, so let's go ahead and plot the data and then see what it looks like. So let me do a line plot. Okay, so now you can see, okay, 1 2 3 4 1 2 3 4 1 2 3 4, it has the same pattern, and you can also see a slight trend going, like that. So you have to format this properly, but we have done that before, so I'm not going to spend time on that. So let's look at how we compute the centered moving average and why we have to compute centered moving average. And as you can see, there is trend involved. So when you compute the average, overall average is not going to be useful for computing the seasonal ratio. Okay, like if you average the whole thing and divide it into each quarterly average, it's not going to work properly. It won't be accurate. Okay. So I'm going to use a slightly different method than in the book. Your book is a little confusing in my opinion. Okay, so what we're going to do is we're going to average, right? Here, suppose if we just find an average, so there are 4 seasons, 4 quarters in a year. So we find the average of these. All right. Now we call this moving average because we're going to copy this down. Okay, we are not using this as a forecast. Okay, don't confuse this moving average with the moving average we did for forecasting. In that, we use moving average of past historical data into an average to forecast the future. So if you use moving average 3, then you use average of these 3 for a forecast for the 4th period, and so on. But here what we are trying to do with moving average is to deseasonalize these data, okay, strip them of seasonality so we can do a ratio. So for that we want to look at, so one whole year, what is the typical value, right? What is, when you average the seasonality out of it, then what would that value be? So you want to use a set of values for one full cycle and be able to use it as the central value. That's why we average the 4 seasons. Okay, but when we have 4 seasons, the average, if you take the time period and average, so the average you'll get is 2.5. So 4 plus 3, 7 plus 2, 9 plus 1, 10. 10 over 4 will be 2.5. Right? So 2.5 is somewhere between 2 and 3 in terms of time. But the sales values are for quarters 1, 2, 3 and 4. We don't have a sales value for quarter 2.5. Right? So this average of 131 actually represents a time value of 2.5, not 3. So if you take that as a typical value for 3, okay, because there is trend included, we have to make sure that the trend part is accounted for. So we are now dividing an average value for T of 2.5 into the actual value of T of 3. So there is a slight discrepancy there. And that's the reason why we have to center it. So what you do is, let's first set up the moving averages. Okay, so make sure that you have covered. So right, the last one should cover the last time period. So these are the moving averages. So this is the average for 1 through 4. This is the average for 1 through 5. So this one corresponds to 2.5 in time. This one corresponds to 3.5 in time, right? So if you average these two, that would correspond to the average of t equal to 2.5 and t equal to 3.5. And the average of that is 3. So if you average these two, okay, that and that, then that average is going to correspond with t equal to 3. So now we have a centered moving average that corresponds with t equal to 3 and the actual value of t equal to 3. So now these two can be used to find the ratio. So take the sales value and the centered moving average, and you have a valid ratio now. This CMA corresponds to time value 3. This actual value corresponds to time value 3. Okay, so now we can copy this. Now remember, this can go only up to here. You can't go here, because if you go here and see, this is going to average these two, but that's not valid, right? So you have to make sure that you calculate only valid centered moving averages and the ratios. So now we have ratio for 3, there are 2 ratios. For 4, there are 2 ratios. So each period has 2 ratios. So what we need to do is to find the average of the ratios. Okay, we'll do that next.